Hi guys, hope everyone's healthy and that you are ready to have a great spring break, or if you're coming back from spring break, hope you had a good one. We are going to go ahead and do number 16 now together. A lot of people had some questions about number 16. So what is unique about number 16 is a couple of things. First, there are some polyatomic ions that you have to recognize, and even if you do recognize polyatomic ion hydroxide, OH, you don't see it right away on both sides. There is, however, something that I told you about that particular polyatomic ion. Think about it and see if you can remember what it is. So remember we said that water was the same as writing a hydrogen and a hydroxide ion. So even though I don't see hydroxide right away on the product side here, I know that water can be written as H and OH because that's the same as H2, because there's two H's in that, and one O. Okay, so now keeping that in mind, thinking water as HOH, here's my list. I've got calcium, OH, which is hydroxide, hydrogen, and I've got polyatomic ion phosphate. Now I see it in parentheses on the reactant side. I can put it into parentheses on the product side too, and that should help me with my counting. So go ahead and try to count them. If I'm going too fast at any point, please just go ahead and pause this. Okay, so on the reactant side, I've got one calcium. Because of this little 2 here, I know there's 2 hydroxides. I've got 3 hydrogens. And again, if it helps you, put that PO4 into parentheses and you only have one of them. If it's in parentheses, there's nothing on the outside, you should recognize there's only one. Okay, on the product side, we've got 3 calciums, 1 hydroxide, 1 hydrogen, and 2 phosphates. Okay, what do we want to do first? I usually just start at the top of the list, so let's start with calcium. How will we fix it? Times 3. Where will we put that 3? You want to put it in front of the whole equation, here in front of this calcium on the reactant side. Since it's the reactant side that needs to be larger, we're going to do it by multiplication, multiply by 3. Now I have not only 3 calciums, but what else have I multiplied by 3? OH. 2 times 3 equals 6. What do you want to do next? I say we're working down the line, and we just did hydroxide, so we're kind of focused on it. How can we fix hydroxide on the product side? Multiply by 6. Where is that 6 going? So we're going to put it in front of the water, or the HOH as I've rewritten it. So we have hydroxide times 6, and we also have hydrogen times 6. Again, please notice that in the beginning I counted 1 H and 1 OH. I did that instead of counting 2 H's and an O, because I wanted to stick with using that polyatomic ion. This is making the problem so much easier than if I would try to count hydrogens on both sides and count them in every place that they were. Alright guys, what do you want to do next? How about focus on the hydrogen? Multiply by 2 on the reactant side. Where will that 2 go? Yep, right here in front of the 2H3PO4. What else changes? PO4 is also multiplied by 2. And if we look, we've got 3 and 3, 6 and 6, 6 and 6, 2 and 2, and now we have a fully balanced chemical equation.